NASA scientists had no idea what they were signing when they launched their last-generation James Webb Telescope on December 25, 2021, from the Guyana Space Center. Astronomers were waiting to find life tracks in the atmosphere of distant planets and galaxies. But little did they know that the first images to arrive from James Webb would revolutionize shape, as we perceive outer space. The mysterious light detected by the incredibly powerful telescope could be just the evidence we needed to confirm that another planet out there could have signs of life. NASA has just launched the first images captured by JWST, and US President Joe Biden called this mission a new window into the history of our universe. NASA Administrator Bill Nelson had promised that humanity would soon have an absolutely unique view of the cosmos, unlike any other we have seen before. Today we are going to take a look at the information that the James Webb Telescope has provided us and what it really means. Is the peculiar light really a sign of life or life potential on a planet orbiting a star completely different millions of miles away? Could it be the super-Earth with which we are all counting? And what else is out there? In order to understand what the most advanced telescope in human history has uncovered, we need to take a step back and learn more about this miraculous invention. NASA, together with its two partners, the European Space Agency and the Canadian Space Agency, operates this huge James Webb Economic Telescope. An administrator of NASA who supervised the Apollo program in the 60s cost about $10 billion to build this powerful telescope. But scientists believe that more than compensated time and money invested in its creation, and the images received from JWST show that they were absolutely perfect. It is undoubtedly the largest and most powerful space science telescope in human history, but NASA took about 25 long years to design and develop this true masterpiece. Today it is operating at an impressive temperature of -266.75 degrees Celsius, which is even just a few points above absolute zero, which is -273 degrees Celsius. In order to keep this temperature impossibly low, the James Webb Telescope orbits around the Sun instead of the Earth, as our own Hubble does. About 1.5 million kilometers from Earth, there is a point called Lagrange L2 point, where JWST remains all the time. This is how it can safely orbit around the Sun while maintaining its excellent temperature. It is designed to observe a frequency band lower than Hubble. Mainly the length of the long wave of visible light, it can visualize wavelengths between 0.6 to 28 micrometers. Its primary mirror is made of 18 segments of hexagonal mirrors made of golden gold. They combine to form a 6.5 meter diameter mirror. The James Webb has two infrared cameras. The first is near-infrared, also called NIRCam, which captures the length of the shorter infrared wave, and the second is the mid-infrared instrument, also called MIRICAM, which captures longer wavelengths. Photos vary depending on which camera was used to capture. It also uses a 5-layer solar shield built from Kapton to block the light and heat of the Sun, the Moon, and also the Earth. So far NASA has provided us with 5 images captured by this giant and unique telescope. And to say the least, these images are incredibly hypnotizing. Stars emitting spectacular blue and orange light, dancing galaxies and strolling around one of the others in a tangle of stars and dust clouds, and some of the oldest lights in the known universe, emitted 13 billion years ago. All this and much more was revealed by NASA in the press release held on July 12. But what if the initial images revealed so much, what the next James Webb data can see? And all this is good news. So far the information obtained seems quite harmless, but you never know when things can really change. After all, NASA hopes the telescope will be able to penetrate the dust clouds and see the light from the farthest corners of the universe. A universe that can be as dangerous as exciting. The most intriguing part of the data obtained from JWST is not even a photo. In fact, they are spectrographic data from the WSP-96b planet. This is an exoplanet about 1,150 light-years from us. Any planet outside our solar system is considered an exoplanet. In addition to NIRCam and MIRIAM, James Webb is also equipped with an image generator without fins or nares. It measures the intensity of various wavelengths of light. The nares mounted on JWST measured the light from the WSP-96b for about 6.5 hours and drew the data obtained in a graph. And according to these data, there may be water on this planet. This gas planet, in its majority, measures almost half the mass of Jupiter. It orbits its native star so close that a year on this planet is equivalent to only 3.4 days on Earth. This rapid orbital period is extremely important, as it is the reason why astronomers were able to study how the molecules on this planet absorb and then emit the light from their star there. By breaking this spectrum of light into its constituent wavelengths, scientists were able to discover the type and amount of elements present in the atmosphere of this planet. The graph representation of these data helped scientists to conclude that there is water in the WSP-96b. In fact, there is a good amount of water vapor in the atmosphere of this planet. Despite the hope that this image provided us, it is too hot to shelter any type of life. The temperature in the WSP-96b is around 530 degrees Celsius. But in the coming months, this telescope will be pointed towards a different planet and take images of it. This is considered potentially habitable, but we will not go ahead here. However, scientists believe they can use images of spectra from many other planets, even outside our solar system and galaxy, thus advancing their search for any signs of life in the most distant corners of the universe. Another main target of the James Webb Space Telescope was the group of 5 galaxies firmly connected to about 290 million light-years away from us. This group of galaxies is called the Stiffen Quintet and is located in the Pegasus constellation. According to NASA reports, 4 of these super-close galaxies are continually passing one after the other at a dangerously short distance, putting them at risk of collision. The amazing high-quality image reveals that 2 quintet galaxies are in the process of merging with each other. Of this 5, the one on the left is closer to our solar system than the others. It is about 40 million light-years away, and that is why the image of this galaxy has a higher definition. Scientists can use information about groups of galaxies like this one to understand how gravity behaves on larger scales. This can also help them to learn more about the mysterious invisible entity, more massive, called dark matter, which is supposedly maintaining the universe. The next image shared by NASA portrays the most impressive cosmic baby boom you've ever seen. This bright and glassy star formation hot is located approximately 7,600 light-years away from Earth in the southern constellation called Carina. What seems to be a landscape full of mountains and valleys splashed with bright stars portrays the edge of a young star formation region in the Carina Nebula. Astronomers believe that this is one of the most active regions for the formation of stars they've ever seen. It is home to many stars much larger than the Sun. Scientists studied the Carina Nebula in detail before, but this new image apparently reveals the cosmic cliffs with unsoundable details. The immensely powerful James Webb Space Telescope is helping us see hundreds of newborn stars that were invisible to the oldest telescopes. NASA officials have stated that this image is so clear that now they can see dust jets and redemoines spinning through the image. These created mysterious structures that scientists still can't even identify. Using the knowledge gained from this image of the nebula Carina, scientists want to discover everything they can about the birth of stars. They believe that this may even allow them to explore the origins of our solar system. The following image that this spectacular telescope brought is the nebula-shaped light portrait of the South Ring. The H-shaped dust cloud and gases are the reason why it is also called the Nebula of the Eight Breaks. It is located almost 2,500 light-years away from Earth. A fascinating orange foam of molecular hydrogen can be seen spinning around a bluish cloud of ionized gas. All of this is being seen by the visible nebula-shaped star in the center of this image. The infrared image of the same nebula shows a second red star shining next to the bright blue star. Now, scientists were always aware that the nebula of the South Ring is a binary system, but this is the first time that the second star is so clearly visible between a thick dust cloud. However, like all the other images captured by JWST, many clearly visible galaxies seem to be bombing the bottom of this image. This points to all the secrets still undiscovered that we may unravel soon. Taking a closer look at this image, scientists noticed a small and faint visible star on the upper left. NASA astronomer Carl Gordon predicted that it was just a part of the nebula, but after carefully looking at it with the 2 infrared cameras, they realized that it was the side view of a galaxy. So, the inexplicable and enigmatic light detected by JWST was actually a whole galaxy that we could have ignored. There is a chance that dust particles being thrown into space by the dying star may eventually merge to form seeds of future stars and planets. A deeper analysis of this nebula could help researchers understand the cycles of death and stellar rebirth. Before any other image captured by JWST gave us a glimpse of the deepest image of our universe on July 11, 2022. This is an image of the galaxy cluster known as SMACS 0723. This extraordinarily high-resolution and high-definition image provides the deepest view of the impressive universe of which we are a small part. In this image, we can appreciate the light emitted by the galaxy cluster at 13.5 billion years. This is very close to the estimated start of the universe 13.8 billion years ago. This image of the deep field of the JWST shows its ability to take advantage of the gravitational forces of the galaxy clusters. It then expands distant galaxies behind these clusters, providing scientists with an incredibly clear view. The SMACS 0723 cluster we see in this image is about 2 billion light-years away from Earth. The images of this ultramodern telescope have brought relief to scientists who have been anxiously waiting for the success of this project. They have great hopes for this mission that aims to transform our view of the cosmos. However, this was not easy to achieve. These high-resolution and colorful images are the culmination of NASA's 20th anniversary project to launch a space observatory for the next generation. A revolutionary successor to the iconic Hubble Space Telescope. The James Webb Space Telescope is 100 times more powerful than the Hubble and is now fully reserved for its first year of scientific operations. Scientists are waiting to make pioneering discoveries using the information obtained with this telescope, whether black holes or cosmic expansion, or even the first origins of the stars. Science is on the verge of exploring unsoundable possibilities on all fronts thanks to this extraordinary invention. Tell us in the comments what you think about the innovative and ultra-advanced telescope and the disconcerting view of the cosmos it has provided us.